Good morning, all. I welcome you all for the day 3 session of Atal sponsored 5 days faculty program. I'm glad to welcome Mr. D. Hari, Assistant Professor, Department of Computer Science and Engineering, Dr. Mahalingam, Engineering and Technology.
Gauri ma'am, it's echoing back.
Yes, ma'am. Sorry, ma'am.
Okay.
I'm glad to welcome Mr. D. Hari, Assistant Professor, Department of Computer Science and Engineering, Dr. Mahalingam College of Engineering and Technology for today's session. He has 10 plus years of teaching experience. His research interests include artificial intelligence and human-computer interaction. His area of interest is augmented reality and virtual reality. He was working in the field of augmented reality and virtual reality for the past 3 years. Now,
Thank you, Gauri ma'am, for your introduction. So myself, Hari. So now I just want to thank our principal sir and our HOD ma'am for giving this opportunity to present this session. So I'm going to share my PPT. Gauri ma'am, is my PPT visible?
yes, sir, it is visible, sir.
Okay, thank you, madam. So this is a topic what we're going to cover now. So we're going to I'm going to cover about the extended reality technologies. That is mainly we're going to focus on virtual reality and augmented reality, and also the working principles of our virtual reality as well as augmented reality. So this is the content of my presentation. So first, I'm going to give the brief introduction about what is extended reality, and we're going to discuss about what is virtual reality and its working principles, and then I'm going to cover the augmented reality as well as working principles of our augmented reality. And I just want to brief about what is mixed reality. Okay, so this is a flow of our presentation, right? So first, I just want to introduce you what is extended reality. So extended reality is an emerging umbrella term for all immersive technologies. So extended reality is a newly added term to our dictionary of technical words. For now, only a few people are aware of XR. Before that, they are speaking about. They are separately. They are saying that is virtual reality as well as augmented reality. So now the terms are combined into the umbrella term. They combine into the extended reality. So the extended reality refers to all real and virtual combined environments and human machine interaction generated by computer technology and wearables. Okay, so that we call this extended reality. So which includes all its descriptive form of like augmented reality, virtual reality, mixed reality, as well as nowadays people are speaking about cinematic reality as well as system some other reality also. So for example, there's so many kind of realities available nowadays. Okay, so in other words, the extended reality can be defined as the umbrella which brings all three realities. Now we are speaking about augmented reality, virtual reality, as well as the mixed reality together under one term. Okay, so this we call as extended reality. So extended reality provides a wide variety of vast number of levels in the virtuality of uh, partially sensor inputs to immersive virtuality. So we'll see later how it works. So let me say the one we already have today, the augmented reality, virtual reality, and mixed reality, plus those that are still to be created. Okay, so cinematic reality, then they may speak about so many kind of reality. So these are all combined into extended reality. So now I just want to focus on virtual reality. So the virtual reality is a fully immersive reality. Okay, so the person should have their own head-mounted display. Then only they can feel the virtual reality is possible. So virtual reality is an illusion of three-dimensional interactive computer-generated reality. We're going to simulate sight, sound, and sometimes even touch. Okay, so this is important in this case of virtual reality. Okay, so we may create by means of pictures, sounds, and objects. We're going to make it into real. Okay, so the person who is working with virtual reality, or we are a person is should feel the actual thing. Okay, so that is important in this case of virtual reality. Okay, so the first challenges of our virtual reality is we must allow the user to view the environment from any point and at any angle. If the person is weird, his head-mounted display, if he turn left, right, or if he see up or down, should view all the ways. Okay, so that is important thing. So according to the person's direction, we need to simulate our environment. We need to create the environment. That is also another important thing. Okay, so virtual reality must allow the user to interact with the objects. Is another important thing, the interaction. Okay, so some of the objects we may create, and we need to interact in the real time. Okay, so this is also important in this case of our virtual reality. Now we're going to discuss about what is the types of virtual reality. So first type of virtual reality is immersive virtual reality. So this is a important virtual reality. Nowadays we are speaking about this one only. Okay, so immersive virtual reality, we need a special purpose equipments. So like if you see here, okay, so in this case we have the system is there. The input devices is there, for example, joystick or some other kind of input devices, and speakers is there, and touch and gloves is there, as well as we have mic and the head-mounted display. These things we need to combine, and we may produce an immersive environment to the user, okay, of this virtual reality. Okay, so that they thought, or they think that they should be in real environment. Okay, so only they can feel the presence of this immersive virtual reality. Nowadays we are speaking about this immersive virtual reality only. Say another type of virtual reality is desktop virtual reality. Is a good example for this desktop virtual reality is if you are working with Unity, if you created some environment, and if you produce before testing the app, we can test in our desktop system itself. Okay, so this kind of virtual reality we call this desktop virtual reality. Okay, so before make it into applications, we may test it into desktop itself. Okay, so that this is the example for this desktop virtual reality. So the use of monitor to display the visual world. Okay, so we're going to use a monitor. Okay, so we don't use any kind of special hardware, so we just see through the monitor. Okay, so this one is very low cost, and as well as it gives low performance, and it provides us less immersion, so we can't feel the virtual reality. So this we call as desktop virtual reality. Is the testing purposes we can use this kind of virtual reality. Okay, so third one is telepresence. Okay, so telepresence is another kind of virtual reality. We have two kind of telepresences. One is real-time telepresence, and the second one is delayed telepresence. So the real-time telepresence interactions are reflected to the some real-world object that is done and the. Okay, so that we call as real-time telepresence. If it is delayed telepresence, means we already created the video or some other thing. Okay, so objects, then we may create the interaction. So interactions are recorded, and then after satisfaction is applied to the real-world object. Okay, so this is we call as delayed telepresence. So there's another kind of virtual reality. And the fourth one virtual reality is we call as augmented virtual reality. Okay, so the computer generated inputs are merged with the user's view of the real world. Okay, so this is we call as augmented virtual reality. So we discussed about the four kind of virtual reality. So one is immersive virtual reality, and second one is desktop virtual reality, and third one is telepresence, and fourth one is augmented virtual reality. Okay, so we move to the next topic, that is components of virtual reality. Okay, so if we speak about the component of virtual reality, we have two components there. One is virtual reality hardware, and second one is virtual reality software. Right. So if we speak about the virtual reality hardware, We may classify our virtual reality hardware into this kind of things. One is primary user input interfaces, and second one is tracking interfaces, and third one visual interfaces, and fourth one is auditory interfaces, and haptic interfaces, and olfactory interfaces. Totally 6 kind of virtual reality hardware classification is okay. So this kind of classification is for our purposes only, right? Now, first we're going to speak about the primary interfaces. Okay, so the primary interfaces are we may call the older one, that is traditional one, that is keyboard, mouse, joysticks. Okay, so we may interact using this. We can interact with our device. Okay, so virtual reality device. So this kind of interfaces we call as primary interfaces. So here I'm showing some kind of primary interfaces or 3D pointing devices may used for this kind of interfacing. Okay, so examples are Spaceballs, and Cyberwand is another example. So here I'm showing the Cyberwand. So another thing is ring mouse. So okay, so this ring is acted as a mouse like that. Okay, so this we call as ring mouse. And fourth one is EGG. Okay, see, EGG is another kind of input device, primary input device. Then we may give so many kind of input to our system. So we have the whole hand or body input devices. Okay, so another example for this kind of input device, primary interfaces input devices are one is the fifth glove. Okay, so the name is fifth glove. Okay, and second one is hand master. Okay, so this we call as hand master, and we have some arm master as well, and we have the TCAS, a transformer condition assessment system. Okay, we have the transformer condition assessment system dataware. So this is for accessing the whole body movement. Okay, so we need to track the user's whole body position. Okay, so only we can interact with the system. To do this, we have the transformer condition assessment system is used. And now we are moving to the next interface. Okay, that is we call as tracking interface. Okay, so the tracking interface used to measure the head,
Hello.
body. Madam, excuse me.
Sorry for interruption.
Yeah,
Sir, actually, I'm not able to see your screen. Or is it a problem for my side, or like others are able to see? No idea, sir.
Gauri ma'am, can you?
Sir, I'm not able to see. No, sir.
Yeah, just a moment, ma'am.
Okay, is it?
Ma'am, it is
Yeah,
visible
just
to
a
us,
moment.
ma'am.
Okay, I think it's from my side then. Okay, I'll try to reconnect.
Hari sir.
Okay, ma'am. Okay. Ma'am.
For
Madam,
Valarmadi ma'am also the slide is not visible. I hope you can unshare once again. Stop sharing
okay.
once again and again you redo it.
Okay.
Okay.
So it is visible, sir.
Hari sir, it's visible now.
Okay, ma'am. Okay. I just continuing. Okay, so that.
Okay, the participant also have claimed that it is visible for them. No issues. You may
Okay,
continue.
thank you.
Sorry for the
Thank
interruption.
you. Thank you, ma'am. No issues, ma'am. Please. Okay, so I'm continuing my session. So we are speaking about tracking interfaces. It is used to measure the head, body, hand, or eye motion. Okay, so the major characteristics of our tracking interfaces are very important thing is we need to find out the resolution. If the resolution is very high, means it will be provide us a real presence. Okay, so another important thing, the accuracy. So nowadays we are speaking about the accuracy. So how much accurate it is. So this is also it plays a major role for tracking. Okay, so how accurately the motion of the objects are tracked. Based on that, the real feeling will be effective. Okay, so then system responsiveness based on a system response is how our system is working. So it may calculate it based on the sample rate, data rate, update rate, and latency. So these are all the things. If, for example, if I'm changing my slide, but the visibility is the issues. Okay, so this is we call as latency. This kind of latency may affect the presence of our virtual reality. Okay, so feel of our virtual reality. So this is a major problem. Then what are the major technologies we're going to use for this tracking? Means one is magnetic technologies. Going to use some kind of sensors and acoustic sense technologies to measure the sound effect and all. And we have the optical technologies used for this purposes. So this is tracking interfaces. So in this case, we have the head and body tracking, and we have these kind of devices we can use for head and body tracking, and we have the eye tracking devices also be there. Okay, biomouse and DPI, eye tracking. So these are all the devices we can use for tracking the uh, uh, motion of the object. Okay, so I'm going to next interface, that is visual interfaces. So the important factors going to before I introducing the what is visual interface, the important factors we need to consider, okay, for this visual interfaces are first one is field of view. Okay, so the field of view is nothing but open observable area the person can see through is uh, our eyes or via an optical device. Okay, that we call as field of view. So once if you use head-mounted display or some other devices, okay, how long or what are the area you can see? Okay, so that we call as field of view. So based on that, we need to simulate our environment. Okay, that is the important thing in this case of visual interface. And another factor is resolution. So the screen or some other thing we are going to project is nearer to our eye. Okay, so the resolution of our the interface is another important factor to give the feel of the virtual reality. Then refresh rate is another important thing, and brightness, color, these things are also affect our visual interfaces. So the basic visual interface are head-mounted display. So here I'm showing some kind of head-mounted display in long back. Okay, so from here we come to our HoloLens or Google. I mean Samsung Gear, some other devices. Okay, so this boom is another device. So it used to this is the boom device. Okay, so the fourth one here is we call this a boom device. So here this is used to identify. Okay, so used to track where the person is viewing. Okay, the eye motion as well as their body motion and all. Okay, so this we call as visual interfaces. And we have the for visual interfaces to communicate with our virtual reality system, we may use stereographic glasses. Okay, so we have two kind of glasses. One is shutter glass and plastic glasses is there. The stereographic glasses is nothing but it is used to convert our 2D images into 3D image. Okay, so that we can use our stereographic glasses for this purposes. Okay, and we have auto stereographic is another technologies. Nowadays, we are using this auto stereographic because we converting our 2D things into 3D thing. So if we are using some kind of head-mounted display, okay, so Google VR or some other displays, we can use HDVD now. Okay, so it automatically auto stereographic things is working now. Then we coming to auditory interfaces. So for interacting with the virtual reality, we need auditory interfaces. Okay, so we're going to use a technique that is aerolation. Okay, so aerolation is nothing but 3D simulation of complex acoustic field. Okay, so this we need. Okay, so for auditory purposes. And one more thing is sonification. Okay, so the sonification is nothing but audible display of data. Okay, that we call as sonification. And of course, we need speech recognition to interact with our virtual reality system. Okay, so I mentioned some of the devices here. These devices are used for this kind of auditory interface. Okay, and I'm moving to the next one, that is haptic interfaces. Okay, so haptic interfaces to provide a touch, and nowadays haptic interfaces plays a major role because we're going to touch something and we interact with some of the devices. If you do so, then how the system is going to be react as, how the reality, that is virtual reality, is going to be react as. Okay, so for this, we're going to use this kind of touch interfaces that we call as haptic interfaces. Okay, so in this case, this is we call as tactile. So in this, the example for this one is cyber touch is developed from University of Salford. So this is we call the cyber touch. Okay, so first two images are belongs to our cyber touch. And another touch for this, we can use kinesthetic, that is force-based interfaces. Okay, so force-based interfaces we use Optic Monster and Phantom. So this kind of devices. Okay, so the image that is in 3 and 4 are our kinesthetic interfaces. And we coming to this olfactory interfaces. The olfactory interfaces we are extending our virtual reality into some other levels. Okay, so for this is a very latest technology. This olfactory interfaces. So olfactory is nothing but to sense our smell. Okay, so smell. So we provide a presence. We provide a real presence to the user, or to provide the real presence to our virtual reality. We're going to use this olfactory interfaces. The electronic nose is a good example for our olfactory interface. For example, it is going to be sense the smell. Okay, so sometimes we need to give smell to the user. We need to provide some smell to the user so that they can feel real. Okay, so that we can use this kind of technology, that is liquid, gel, microencapsulation. Okay, so at the time, suddenly the liquid is evaporated. It provide a good smell to the user. Okay, so for this, we may use some of the product is available in the market. The VOC group, they develop olfactory delivery system, and the University of Wollongong, is another example for this olfactory interfaces. Okay, so we discussed about various kind of hardware components of our virtual reality. Now we are coming to our software components of our virtual reality. Okay, so if it's software component, if we see, so we have four kind of class. We may classify it into four things. So this is for our purposes only. Okay, so we may classify it into input process, simulation process, rendering process, and database. Okay, so I general term I'm using world database. Okay, so this is our environment database. So all the things belongs to environment is stored in this databases only. Okay, first we are going to discuss about the input process. The input process which control the device that sends data to the computer. Okay, so we discussed about various kind of input. Okay, so based on the input devices, we're going to give some inputs to the virtual reality system. Okay, so the input devices should be checked regularly. For example, the frame basis, we need to check this input processor. Each and every frame we need to check. Okay, so what is the input like that? Okay, so we move to the next process, that is simulation process. Yes, sir.
Sir,
So please.
your screen is not visible, sir. The screen. Your screen is not visible. May wrongly picked, sir.
Excuse
Your
me,
chat.
Gauri Shankari, ma'am.
Sir, your
Hari
chat.
sir, Hari sir.
Ma'am.
Yes,
Kindly
whether
hold. Kindly hold, Hari sir. Sir,
Okay,
I
okay.
request participants to please close the browser once again because this was a difficulty which is faced from my colleague also. So what you please do is that if the screen is not visible, kindly, just close this application and again you may reopen it, sir.
that is close the browser and again we have to
Yes, sir. Yes, sir.
reopen the browser.
Kindly, yes, sir. Kindly close the browser and then reopen it
Okay.
again with using the same link, sir. For the
Okay.
participants for whom the screen is not visible, those participants alone, please do the same.
Madam, excuse me, Paitra, madam.
Yes, Hari sir. Solunga.
Madam, is this problem from our side or
No,
some
sir.
other?
No, sir. It's not problem from our side because many other participants for them it is visible only.
Okay, ma'am. Okay, okay, then
Again,
okay.
I have logged in as a guest in my mobile phone for in that also it is visible only. So no issues from my side, from our
Okay,
side.
okay,
Sorry, from our side.
okay. No issues. Oh, then okay, okay, okay.
Kindly hold on for few minutes and then you may restart, Hari.
Okay, ma'am, sure, ma'am.
Thank you. Thank you. Okay.
Okay, now I think the participants are see my screen.
Sir, it is visible now.
Okay, thank you, ma'am. So I'm continuing. So I'm moving to this next process, that is simulation process. So this is the core of our virtual reality program. So the simulation only is going to be handle the interactions, object behavior, simulations of a physical laws, and determines the world status. Okay, so based on that, it simulate the environment. So if you are walking, okay, so walking means if we are walking, then it is going to be create the environment. I just show one video for this one, so you can understand. I think now you can see my screen.
Sir, screen is not visible.
Sir, screen is not visible, sir.
Sir, yes, sir, now it is visible, sir.
Okay.
Yeah, now it is visible, sir.
Thank you, sir. Thank you very much. Okay, so if you see this on this video, if you are walking, okay, if you are wearing our head mounted display, if you are walking means it gives real presence. We are in that environment. Okay, so this should be simulated by our simulated process. So if it should be properly simulated, only we can feel the presence, real presence of we are in our virtual reality environment. Okay, so if the simulation is not working properly, okay, so the system should be simulated according to how we are seeing, where we are seeing, and how we are interacting. Based on that, the simulation system should be react. Okay, so based on that, only we can feel the real and actual presence of our virtual reality system. Okay, so now the screen is visible, I think so. Okay, so we are speaking about various kind of hardware components. Now we coming into the software component. We're speaking about simulation process. So now I think how the simulation process are important. Uh, we know, right? So next we move to the rendering process. The rendering process is nothing but the creation of sensation that are output to the user. Okay, so we have the visual rendering is there. So using polygons, visual rendering, the process is divided into four types. That is, we need to use this kind of technologies to for visual rendering. Okay, so using polygons to represent objects, and second one is ray tracing method and lighting method, and flat versus smooth shading and Z buffering. These are the visual rendering technologies. And next one is the auditory, haptic, and olfactory rendering is another important thing. So how we are going to present these things to the user is we call this rendering process, right? Then final one, we nothing but our database. So database is it is used to store the data uh, as well as the objects on of the world. That is our environment. All the things are stored in this databases. Okay, the data may be ASCII as well as binary is possible, and it may be a single versus single file or data. It may be a proper database, or it may be centralized or distributed one, or standard, or it may be proprietary formats, and it may be in virtual reality modeling language. Nowadays, we're going to use this virtual reality modeling language for this creating the databases. Okay, so what are the important issues we may face on this case of our virtual reality means first one is interaction techniques. We are going to use so many kind of devices. So I previous itself I showed you we are going to integrate our mobile system, head-mounted display, as well as the input devices, various kind of input devices. As well as we are speaking about olfactory interfaces, auditory interfaces, so many things we're going to mix and we're going to produce a system. So the interaction, each and every device's interaction is very major issue for this in this case of virtual reality. And another problem is navigation techniques. So how we going to navigate is another issues in this case of navigation techniques. And if you're going to uh, provide a real experience to the user, we need to find out some collision detection techniques. So two objects are collide each other means how we are going to detect that collision, and how we are going to react for that collision is another important thing. Then level of detail is another important component in this case of our virtual reality. So this is a kind of interaction techniques. So for this kind of interaction techniques, we may use some kind of machine learning algorithms, machine learning and deep learning algorithm to create this kind of interaction. So I'm not going to for depth in this and that, but these are all the techniques we may use for interaction. Okay, so first one is we may create a simple virtual hand. So one object is there, and to interact with that object, we may create some virtual hand. For example, we may convert our mouse it into this kind of hand. Okay, that is possible to motion detection, and I think is coming under the part of our uh, machine learning techniques. And raycasting is another method, and we have the sticky finger method is a fishing reel. This is another techniques used for interaction. And scaled world grab. Okay, so this is used to select, grab, manipulate, release. So if we are doing the real thing in a virtual system, means we're going to use this kind of scale world graph. For this, we may use some kind of machine learning as well as deep learning algorithm to do this kind of things. Okay, so this is nothing but navigation techniques. Navigation techniques is three things. One is steering based. Okay, so to detect the navigation of the user, we may use either by means of direction or velocity. We may use it is classified into hand directed, gaze directed, as well as physical devices we may use for this steering. And target based may point at object or list of coordinates we may use for target based navigation system. And we may have some route planning techniques also we may use. For this also, we may use Venba algorithm to do this kind of things. And next one is collision detection. So I already told you. So it is very computationally intensive, but very important for presence and realism. Okay, so if the two things are two objects are colliding, means we need some kind of techniques to detect this one. Okay, detect as well as we're going to react. You need to react. Okay, so we may use the bounding volume techniques or otherwise Voronoi region or convex decomposition. This are algorithms, and we may use some separating plans, separating planes for this kind of detecting the collision. We may use. Another thing is level of detail. So LOD is another important thing in this case of virtual reality. So when looking the object from a far detail, not important. Okay, so if we are showing one object to the user, okay, it is so far away from the user view, means it's not the much detail for that object is not important, but it is nearer to the user, means we need to provide so many details of the object to the user. Okay, so this is another important thing of level of detail. So one object is hiding another object. So in front of one object is another object is we're going to place in means how the another object, how we're going to hide some details of the another object. Okay, so that is we call this level of detail. Okay, so reduce the number of polygons significantly is another important thing. So line of detail management is one of the another important factor if we consider our virtual reality system. Okay, so it may be automatic or predefined. So based on that, based on the techniques what we are using, so we may give the real scenario or we may create the real environment to the user. Okay, so another thing is distributed virtual reality. So we have one kind of this is another kind of virtual reality. So nowadays we are everything if the cloud is coming to the picture, everything is distributed. Okay, so this gives the multi-user environment. Okay, so distributed virtual reality, multiple persons can work simultaneously is possible. Okay, a simulated world run on several computers, okay, connected over a network is also possible, and people can interact in real time, sharing the same into virtual world is also possible if you are using the distributed virtual reality. Okay, so now the questions comes into a picture how the virtual reality actually working. So the virtual reality requires several devices such as headset, a computer, smartphone, or another machine to create digital environment and a motion tracking device in some cases. Okay, typically the headset displays content before a user eyes while HDMI cable or transfer image to screen from the PC. The alternative option is headset working with smartphones like Google Cardboard and Gear VR. Okay, a phone acts both as a display as well as source of virtual reality content. Okay, so the next key feature is a frame rate per second, which should be 60 frames per second at minimum to make virtual simulation look realistically enough. Okay, so minimum we need 60 frames per second. Okay, for us. Okay, so virtual reality simulation is another important thing. So virtual reality simulation requires two main components. One is a source content of a user device and software and hardware. Okay, so nowadays we may use headset for this one. Okay, so to provide a good feel to the user, we may use treadmills, special gloves, Googles, etc. Okay. So the final thing in our virtual reality is how we are going to measure the performance of the system. Okay, so that we can use image resolution, field of view, refresh rate, motion delay, pixel persistence, audio video synchronization. These are all the methods used to measure the performance, so that we may modify or we may improve our algorithm um, for provide a good feel to the user. Okay, I'm going to the next technology, that is augmented reality. So we already know, we are aware of what is augmented reality. So the augmented reality is superimposing a real image into a virtual thing or virtual image into real thing. Okay, so this is we call this augmented reality. So augmented reality, first initially they designed for medicine as military purposes in US, but nowadays is coming to all kind of applications we can create using in augmented reality. So if we see what is augmented reality is based on the Asimov's definition, it combines the real and virtual world. Okay, so it's the first thing, and it interactive in real time. Okay, so this another characteristics, and the third one is should have register in 3D. Okay, so augmented reality is a 3D technology, is another important factor. So these things, so one of the pioneer, the Sumo, is defined augmented reality, which has the three important characteristics. Okay, so if you see the technology requirement for these things, okay, so combining real and virtual images, we need display technologies. Okay, and to interact with the real time. Okay, so the augmented reality interact with the real time means we need input and interactive technologies. Okay, so we discussed so many kind of interactive technologies in virtual reality itself. Okay, so input devices also. So these kind of devices we need to interact in real time. Okay, so to register in 3D, to provide our environment into 3D. Okay, so we need either viewpoint tracking technologies we need. Okay, so if you see here the input and tracking and technologies based on the input and the tracking, based on that we have process input as well as the tracking. So the tracking is nothing but where the user is seeing and which position the user is viewing. Okay, so that is nothing but tracking. So how whether the person is walking or whether the person is doing some other action means that should be tracked. Okay, so whole body will be tracked. Uh, so this is also given as the input to the processor. Okay, so the processor processed the input, and based on the input, it's going to be displayed uh, through our head-mounted display or some other output device. Okay, so if we see the difference between the virtual reality and augmented reality, so if we see this is a virtual reality, is a fully immersive environment. Okay, so the user needs fully immersive techniques or immersive hardware. Okay, so only the user can feel the virtual reality. But augmented reality no need of this kind of immersive technology. But we need the mobile phone is more than enough to feel our augmented reality. Okay, so this is the major difference between our augmented reality versus virtual reality. So the augmented reality system augments the real world scene. Okay, so the user maintains a sense of presence in the real world. Okay, it needs a mechanism to combine virtual and real world. Okay, so the problem is how to register real and virtual. Okay, so we need to always we need to make it into real thing. Okay, so already real thing is there, and we virtual things we need to superimpose into uh, real thing. So we need to make the virtual things also feels like real. Okay, so this is another important thing in this case of augmented reality. Okay, so if we speak about the virtual reality, everything is in virtual. Okay, so everything is simulated. Okay, so we need a immersive environment. Then only we can understand, we can plus feel the virtual environment. Okay, sensors are under control of system, so the system only control all those things. But in this case of augmented reality, the user direction is another important thing. The user may use mobile phones. The mobile phone directions is more than enough to uh, identify these things. Okay, so in this case of virtual reality, we need a mechanism to feed virtual world to the user, so that we're going to use our head-mounted displays or otherwise some kind of output devices. Olfactory, we speak about olfactory interfaces, auditory interfaces, and as well the display technologies. Okay, so here it is hard to create a fully virtual environment. Okay, so we need to concentrate on each and every part of our designing techniques. So this is another a challenge in our virtual reality. Okay, so if we speaking about the combining real world and virtual world, if you see this picture, okay, so in this, if you see the picture on the left side, this is the actual environment. Okay, so this is nothing but it look like book or some other thing. Okay, so it is a reflective environment or reflective surface. Okay, so if you see this surface, I'm speaking about left side image. If you see this surface through our mobile phone, okay, through our augmented reality application, it shows one ball, green color ball. Okay, so this is what we design through our application. If we consider this one, okay, so if in this case, if we if we feel we are in a realistic environment, the shadows are created here. Okay, because this is a reflexive surface, so we need to create a shadow of our image. Okay, so this is so only the user can feel they are in realistic environment. Okay, and we are moving to next on, that is types of augmented reality. There are 4 types of augmented reality is available today. So first one is marker based augmented reality, and second one is markerless augmented reality. Third one is excuse me.
Some differences. Okay, sir. No problem, sir. You can continue, sir.
Okay, projection based augmented reality, and fourth one is superimposition based augmented reality. So we'll see one by one. So first one is marker based augmented reality. So marker based augmented reality, if you see this image, you can understand what we are doing. So in back side of our image, so yeah, if you see this one, if you backside of our image, we have one marker is okay, sorry, backside of our this mobile. So the person is open their app through this mobile. Using that app, they switch on their camera. So using that app, uh, they focusing the image. Okay, so this is act as a marker. Okay, so now what will happen automatically, if you see through our camera, if you see this image, so automatically one uh, on house is displayed here. Okay, so this is actual thing is real thing is these things. Okay, in this we have superimposing one virtual image. Okay, this is the example of marker based augmented reality. Okay, this is how we need a marker. Okay, so this kind of augmented reality used in so many ways. So for example, if nowadays we are using Google Pay or Amazon Pay, some other thing, we are scanning a QR code. The same kind of technology used in this case of marker-based augmented reality. Okay, now I think we can understand. Okay, so if we speak about the markerless augmented reality, so instead of marker, okay, so the marker is not important factor here, but in this kind of markerless augmented reality, we need a location-based or position-based augmented reality. We need either location detection system or position detection system. So, so particular location or particular position, if we come with our mobile or some other devices, it automatically superimpose our virtual image. Okay, so this kind of thing is based on markerless. So we need a GPS or compass or gyroscope or oscillometer or some other thing we need here to do this kind of thing. But the next one is projection based. Projection based in this projecting a synthetic light to physical surface and some cases allows to interact with that. Okay, so this is another example. Projection based augmented reality. The another one is here we may use some holograms. Okay, for doing this kind of things, and also we may provide some kind of interaction for this one. Is also possible. And the final thing is superimposition based augmented reality. It replaces the original view with augmented or fully or partially. Dr. Amadu will show this kind of example is a good example, as well as Suresh is also, yes, they cover this kind of augmented reality, superimposed based augmented reality. This is mainly used for training purposes as well as repairing some other thing, repairing purposes. This kind of augmented reality is used. Next, we are speaking about what are the hardware requirements of our augmented reality. Okay, so the hardware component for augmented reality is one is processor, display, sensor, and input devices. Okay, so the modern mobile computing devices like smartphone and tablet computers contain the elements that is camera and MEMS, that is micro electromechanical system, as well as the sensors is also available in our mobile phone itself, accelerometer, GPS, and solid state compass. These things are available in our mm, mobile phone itself, so it is easier to identify the location or track the position is easier in by means of augmented reality system. Okay, so if you see this image, we have two kind of tracking techniques we may use. One is motion tracking, and another one is location based tracking. So for motion tracking, we may use camera, accelerometer, or gyroscope is used. It is available in our built-in in our mobile phone itself, so it is not a matter. So no need to separately, we need to combine. Okay. For example, if your location-based system, we use either GPS or magnetometer, we can use for this kind of things. Okay, we coming to this display technologies. Display technologies, either it is monitor-based laptop, cell phone, or projector, or we use head-mounted displays. Head-mounted display, we have two kind of displays. Head-mounted displays. One is video see-through, and second is optical see-through. Okay, so this is a monitor-based augmented reality. So if you see this one, so here we are going to use a monitor. Okay, so here we are going to use the real world is watch through our camera through our real world camera, and we have the graphic system. It is used to generate the virtual object. Okay, we are combining our video of a real scene with our graphic system, that is virtual object. So we are merging two things, and we are combining, we are producing our augmented video that is displayed in our monitor. Okay, this is we call this monitor-based augmented reality system. So for sensing the real world, we are going to use a camera. Okay, so the graphic objects is automatically generated through our graphic system. So the augmented reality system is merging real thing as well as the graphic things, so that we may use so many kind of algorithms, machine learning algorithm. This is mainly based on the computer vision technique. So the computer vision plays a major role here to merging real thing as well as graphics or virtual object. Okay, so we combine these things and produce our augmented video to our display device. Okay, so this is a good example how the monitor-based system is working. The next one is optical see-through. So the optical see-through, okay, so we're going to use some kind of optical. Okay, so if you see here, okay, so this is a system. Okay, so we have the some kind of uh, projector or some kind of glasses, see-through glasses, well, in our in front of our eye. Okay, so the real world is since our real world input is gathered through our this optical device, and we have the scene generator is also available. The scene generator generate the graphical scene. Okay, so if in this case we need to track the head location or head movement, either we are turned into left or right, or we are viewing straightly, these things should be monitored. So we need a head tracker for this one. Okay, so the head tracker track the head of the user, head position of the user. So only we can track exactly where the user is viewing. Okay, based on the view of the user, so we have field of view one of the important factor. Okay, so where the user is seeing, so based on that, the graphics scene will be generated. The scene generator generate the graphic scene, and both the things are matched, and they should be displayed in the optics, that is our screen, nearer to a screen. So example for this one is our Google Glass is a good example for this kind of thing. Okay, optical see-through thing. Right. See the video see-through. Okay, so video see-through, we don't have the we can't see through our optical device. Okay, so our head is surrounded by the head-mounted display like this. Okay, so in this case, the head are fully surrounded by our head-mounted display. Okay, instead of directly viewing some kind of images that is available in the real world. Through the video only we can see. Okay, through the video, through the camera is sensing how the world is. Okay, so, based on the camera input, we have the videos. So in simultaneously the graphics image also be generated. Okay, based on the real input through our camera. Okay, so the two important thing is that we need to track the user head position. Okay, so based on the position, okay, based on the head position, the scene generated generate the graphic image. Okay, so we have the video compositor as there, so it combines so a real world video with our generated scene, that is virtual scene. Okay, both the things are combined. The combined video is displayed through the monitor, displayed to the user by means of monitors. Okay, so here we need a camera as well as head tracker, as well as a scene generator, and these things are combined into one head-mounted display. So nowadays the head-mounted displays are working like this only. Okay, so video see through head-mounted display. Okay, so we based on this kind of techniques, the display techniques are classified into either head-mounted or eyeglasses and virtual retinal display, eye tap, or handheld devices. Okay, this is okay. If you see the head-mounted display, is kind of one kind of display device. It paired to a headset such as harness or helmet. Okay, so this is how the head-mounted display is working. Okay, so a head-mounted display plays the image of both the physical world and virtual objects over user's field of view. Okay, so this is another important factor. Okay, if we speak about the eyeglasses, okay, it version include IVR that employ cameras to intercept the real world view and redisplay its augmented view through the eyepieces and devices in which the AR imaginary is projected through or reflected of a surface of the IVR lens pieces. Okay, so we need some kind of see-through lenses here. Okay, and if we speak about the virtual retinal display, okay, so the virtual retinal display is a personal display device under development at the University of Washington's Human Interface Technology Laboratory. Okay, in this technology, a display is scanned directly onto the retina of the viewer's eye. Okay, so if you Google it, you can understand how the virtual retinal display is working. Because the viewer sees what appears to be conventional display floating in the space in front of them. Okay, so it directly scan onto the retina of the viewer's eye. Okay, if we speak about the eye tap, okay, so eye tap captures rays of a light that would otherwise pass through the center of the lens of the eye of the wearer and substituted each ray of the light for synthetic computer controlled light. Okay, so the generation 4 class is a good example for eye tap. If generation 4 class, you can Google it, you can understand how the eye tap is working. See, the another important thing, handheld displays. Handheld displays nowadays, the mobile is good example for our handheld display. Okay, it may be a mobile or tab or auto-test. We consider this as a handheld display. So for this, if here we're going to use micro electromechanical system, we're going to use MEMS as well as GPS sensors such as digital compasses and 6 degrees of freedom accelerometer, gyroscopes we're going to use. Today, the SLAM, that is simultaneous localization and mapping techniques used for Mark-Alex trackers such as PTM, that is parallel tracking and mapping, is another important techniques used for this handheld display. So this is the tracking techniques, how we can tracking. Okay, the tracking techniques used in our augmented reality. Okay, so now we have the question how the augmented reality is working. Okay, so the computer software recognize the augmented reality marker or black squares. Okay, that contains certain pattern measure each side. Okay, do some complex calculation to determine the position and rotation of the marker in 3D based calculator. This information allows the computer to render photorealistic 3D objects over the marker and display the result in both the handheld visor and on the large computer screen. Okay, the pattern within the marker dictates which 3D object will be displayed and can also trigger narration and sound effect. Okay, markers can be variety of sizes. Okay, so and attached to almost any flat surface, which means they can be used in many interesting and effective ways. Okay, so we can use any if QR code is also we can use as a marker, that is possible. So any kind of things we can use as a marker, right? That is possible. Okay, so now I'm coming into the mixed reality. So the mixed reality is modeling of real-world representation of classes based on the computing techniques. On if you see in this case, real environment is there, and we have the fully virtual environment is there. Okay, so if you see here, this is a real environment. Okay, so what actually exists? Okay, virtual environment, computers generated, or it's a computer simulated environment. In between this real environment and virtual environment, we call in this reality. So real and as well as virtual environment. In between, in this kind of reality, we call this mixed reality. Okay, so the definition for our mixed reality is the mixed reality is everything between augmented reality and augmented virtuality. Okay, so fully virtual as well real thing is that. So in between this, we call this mixed reality. Okay, so the main goal of our mixed reality is the creation of big space by merging real and virtual environment, wherein real and virtual object coexist and interact in real time for the user scenarios. Okay, so this is another important factor. Okay, so mixed reality is a class of simulators that combines both the virtual and real object to create hybrid of virtual and real. See, and Amadhavel is covered. Dr. Amadhavel is covered this how the what is the difference between mixed reality as well as virtual reality as well as augmented reality. See, in this case of mixed reality, we have the enhancement of the augmented reality. That is, augmented reality plus you may provide some kind of interaction with the real-time object, means that is we call this mixed reality. I think now I can you can understand what I'm speaking. That is, we are extending our augmented reality into some level. Okay, we have the virtual object is there in real environment. Okay, so if it is possible to interact with that virtual object, means that is coming under mixed reality. Okay, pure augmented reality, that is not possible. Okay, so this is a comparison. Okay, so based on the three main characters of our mixed reality, augmented reality, and virtual reality. Okay, so the three main characters are immersion, interaction, and information. Okay, based on this, if we compare, means okay, so mixed reality is a real-time spatial mapping for merging and real and virtual. So augmented reality is augmenting the real world. Okay, virtual reality is nothing but fully virtual. Okay, so this is a difference between the three things. If in this case of based on the interaction characteristics, mixed reality is the interaction with physical and virtual object. It is possible. Okay, interaction is possible in mixed reality. Okay, but augmented reality is focusing on interaction with physical object only. Okay, that is existing in the real world. Okay, so virtual reality is focusing on virtual object only. But in this case, mixed reality, we can interact with either by means of physical object as well as the virtual object is possible. Okay, in this kind of information point of this comparison. Okay, so mixed reality registration in 3D space, correlation to the user space, time persistence is possible. Okay, but virtual reality is high comparatively. That is registration in 3D space, no correlation to the user space, no time persistence. Okay. But augmented reality is unaided in 3D space, no correlation to the user space, no time persistence in this case of augmented reality. This is a comparison of our things. Okay, so what are the challenges of our mixed reality? Okay, so creating a platform is another for creating the mixed reality platform is the main challenge. Okay, it requires the display technology and the tracking. So we are speaking of the main issue of the tracking is we are combining so many kind of devices into um, one location. That is one system which has so many kind of tracking devices. It may be many kind of sensors, many kind of input devices, many kind of output devices. These things we combine, it produces one single system. So creating a platform, combining to creating interfacing, all these things is a very tough task. Okay, so my mixed reality platform needs to use appropriate display technology to provide reasonable output with appropriate resolution and contrast. If you're providing like this, only the user can feel the mixed reality. Otherwise, uh, uh, the user won't like our application, right? In some instances, the system needs to consider the user perspective. So another important factor. The interaction between the virtual and real object require the use of trace method in order to track both objects. So this is the steps of our mixed reality. So the first step is to create a mixed reality environment using see-through technologies. Some steps are required. This kind of steps are required. Okay, in the device recognition steps, the types of mixed reality tools to be used, such as see-through or camera, are identified based on the project aims. Then the device are set using the calibration model. And in the space recognition step, modeling space is performed to model some part of the real world in the virtual environment to run the user scenario. In the object and tracking recognition step, the real world object is identified and tracked. In mapping recognition, registration and mapping are performed to communicate between real and virtual object. Okay, this provides a interaction between the virtual and real object. Okay, so then in visual recognition and mixed reality service is implemented and then visualized using appropriate computer graphics techniques. This steps overlays the virtual objects in the real world scene. In portable recognition, an appropriate model is used for data delivery and scene reconstruction. This model reduces unnecessary information. And finally, on the portable recognition is used for mobile device. Okay, all these steps are needed in appropriate analytical model. Okay. Okay, this is a mixed reality algorithms where what are kind of algorithms we used in mixed reality. Okay, so we're going to use the calibration algorithm for correcting our some kind of errors and something. And visual rendering is another algorithm, and object recognition algorithm we need, and registration and mapping algorithms we need, and model of space simulation algorithm. Information transfer for portable devices, another kind of algorithms, object tracking algorithm. So this kind of steps are combined, we may produce our mixed reality. Okay, so this kind of algorithms are needed to produce our mixed reality. Okay, so I'm coming to a conclusion. So this is the role of role of extended reality in industry. So if we see here, so we have the red color or repair and maintenance, and the gray color belongs to design and assembly. So view reference videos and digital manuals. This is plays a major role. Okay, view references and videos, reference videos and digital manuals plays 31% they used in company side. Okay, this belongs to 2019 survey. Okay, remote export assistance is 30% so used, and visualize specific components and function behind the physical barriers that they use 30%, and superimpose step-by-step instruction 29% are used. Simulate product performance in extreme condition, 28% are used. Visualize infrastructure project from various angles, 28% used. And view digital instruction for assembly and configuration, 27% used. Overlay design components onto existing module, 26% are used. Okay, these are all my references. Okay, so I'm concluding here. So thank you for your patience. Now I'm just recalling Miss Brinda ma'am. She helped me a lot for this kind of lecture, as well as she helped me in this level. Thank you all. Participant, do you have
Thank you,
any
sir.
questions?
Participants, The session is now open for you. If you can interact with the resource person. Participants, you can interact with the resource person. If you have any queries, kindly unmute yourself and you can interact.
Hari sir, you have made a very nice presentation of all these technologies and other things.
Thank you,
Uh,
ma'am. Thank you very much, ma'am.
Actually, you were talking about that machine learning algorithms used for these interfacing techniques. Can
Yes, ma'am.
you elaborate on that?
Sure, ma'am. For we're going
Hello,
to
sir,
use.
am I audible?
Yes, yes, ma'am. Yes, ma'am. Yes, ma'am.
Hello?
Ma'am, audible, ma'am. Am I audible to you?
Yes, sir. Yes, sir. Now you are audible, sir.
Thank you, ma'am. Thank you, ma'am. We're going to use various kind of technologies here, ma'am. We are going to use calibration as well as tracking. Okay, for tracking, we're going to use some kind of because we are going to combining two important things, ma'am. Because real videos are in that we are going to combine virtual object. Okay, so to positioning, we need some kind of image processing algorithm. In this video, if real videos are to positioning our virtual object into particular position, we need a image recognition algorithm. Okay, so for calibration also, we need for real time we need to correct the error. Okay, so only the user feel exactly. So for that we need some kind of calibration algorithm, and we have some another rendering technologies. Also, we need some kind of image processing. Okay, and we have computer vision techniques. Mainly in our augmented reality, virtual reality, computer vision techniques plays a major role, ma'am.
Yes, sir. Thank you, sir. Actually,
Thank you.
this yeah, the rendering process, it happened to be a very what to say, the time-consuming process. Is it not, sir?
Yes, ma'am. That is the
Rendering.
problem in this case of our virtual reality, augmented reality. Okay, so, that we need a high-end processor and to processing and display rendering to the user. So we need some kind of yes, ma'am. This techniques are very important.
So we need a high-end configuration also.
Yeah. Yes, ma'am. Yes, ma'am.
Thank you, sir.
Sir, can I ask one question?
Yeah, yes, ma'am. Please.
Sir, like if we are using computer vision approaches in augmented reality, no, sir, then how
Yes,
can we how can we say like computer vision and augmented reality are interrelated with each other, sir? Like what type of relationship can we explain between the two?
Yeah, sure, ma'am. Sure. That is what I'm speaking. Okay, so, ma'am. Actually, if you are
Okay.
directly, if you are creating our application through our Unity or some other tools, we can't see, we can't feel, right? But if you are implementing rendering process or recognition, object recognition, we are combining. Augmented reality is superimposing the virtual object into our real thing. That is, real video is there. Camera is switched on, the real video is capturing. In that, we are superimposing some objects. So for this, we need a image processing algorithm. So that is one kind of computer vision algorithm.
Vision.
Yes. Okay, to do this kind of things, see everything is related to this kind of computer vision algorithm only, ma'am. Calibration process, object recognition, and registration and mapping. Okay, so exactly we need to positioning particular object into a real video. Means we need some kind of image processing algorithm.
So
And
can
tracking also, ma'am. Tracking for tracking the where we are in. For tracking, for example, markerless augmented reality, based on the tracking methodology only, we can use this kind of. For example, we need a GPS data to
yes,
process GPS data where we are in. Then only we may project something based on the location. We may project some steps to the user.
so that
So we
means
need,
computer vision algorithms will be used in order
yes, ma'am.
to help us perform augmented reality, right?
Yes, ma'am. Yes.
Thank you, sir.
Thank you, ma'am. Thank you.
Hari sir, there is a question in the chat box.
Please.
Sir, is there any possibility of XR technology be implemented in any area to attain sustainable development?
Actually, the XR technology is applied in so many areas. It is possible, sir. Actually, if we think creatively, we can apply our extended reality technologies in any area that is possible. Okay, so XR technology is not belongs to a particular engineering field. It is common to open for all. The advertisement and so many kind of applications are developed using this XR technology in so many ways. Okay, so we have some creativity and we have some knowledge about that particular area. We can use XR technologies in any field that is possible. Ma'am, I think now.
Any more questions from the participants? Okay, if there is no more questions, we shall conclude the session. Gauri ma'am.
Okay, ma'am. Thank you, sir. The fundamental concepts of augmented reality and virtual reality has been clearly explained, and we found it very much useful. I extend my thanks to Mr. Hari for the wonderful session. Thank you, sir. Participants,